And away we go. We're moving. They were the machines that made Britain great. Fast, revolutionary, and sometimes downright dangerous. These are the stories of our engineering masterpieces that shook the world and drive the way we live today. If any one decade can claim to have the greatest impact on human history, it might just be this one. It's the 1940s, and the world was at war.
It was a war we had tried hard to avoid. And when it happened, it was very different from the war we'd expected. Hitler's mighty technological war machines swept through Europe.
Britain was determined to stand firm. As Churchill declared, "We shall defend our island, whatever the cost may be. We shall never surrender."
The threat of invasion sparked an unprecedented period of innovation, ingenuity, and improvisation, producing an amazing variety of new machines, unsung heroes of World War II, and the roots of modern Britain.
Life would never be quite the same again, because war really was the mother of invention.
May 1940. The greatest retreat in history begins. Following a crushing defeat by Germany in Europe, 330,000 Allied troops are rescued from Dunkirk.
For 9 days, hundreds of ships and boats raced between Dunkirk and the English coast. There were dark days ahead, and Britain was ill prepared for war.
The mighty German army was now encamped just 46 miles from Britain.
From July 1940, the skies over the English Channel were filled with thousands of German aircraft. We faced the greatest threat of invasion since 1066. The Battle of Britain had begun.
Angels 1-6, Willie Victor 3-4.
Scramble 222 and 504. Intercept Chelsea Bill.
Vastly outnumbered, our pilot's lifeline was a new experimental machine that shared its technology with the latest household gadget.
This is London calling.
The whole fury and might of the enemy must very soon be turned on us.
At the time, few people knew what a radio wave actually was. Some even believed it could have potential as a lethal weapon.
In the 1930s, the Air Ministry, in all seriousness, offered a £1,000 reward to anyone who could demonstrate a radio wave death ray that could kill a sheep at 100 yards.
The turning point came when they approached top British physicist Robert Watson-Watt. They asked him if he could generate a beam of radio waves so powerful it could destroy an enemy aircraft.
Watson-Watt calculated the required energy levels as wildly beyond existing technologies. He also pointed out that the metal fuselage would protect the crew from the radio waves. But he did have another very useful suggestion.
He calculated that even a normal low-power radio wave like those used by the BBC's broadcasts would bounce back off a metal aircraft. So instead of radio destruction, he suggested radio detection. Just 2 weeks later, in a field near Daventry, Watson-Watt made his first attempt to demonstrate his invention: radar. Using modern equipment, here's my version of that historic day.
In here we have a radio transmitter and a detector, and over here we have a display screen. Now, back then, the equipment would have been much bigger, but the principle is exactly the same.
First, the transmitter emits short pulses of radio waves.
So I'm beaming radio waves across 90 degrees in that direction. According to this screen, there's nothing out there that's moving.
With a clear line of sight, radar can see much further than the naked eye.
Well, yes, I'm seeing a blue blip at the top of the screen.
My radio wave pulses are reflecting off a moving object.
It's just going from left to right,
Based on the time it takes for the echo from each pulse to return to my detector, the radar system can calculate the range and speed of the object.
Right, a range of 301 meters, radial velocity, or speed, 4.46 miles an hour. And it represents the only moving thing that's out there, which is a BSA M20.
With his first prototype, Watson Watt detected a bomber 8 miles away, 4 minutes before it reached his position.
He had a working early warning system, and it went on to be one of the most important British machines ever created.
In 1936, a chain of radar stations began to appear around the British coastline, codename Chain Home. Each had 4 350-foot tall steel masts to send out the radio pulses. The echoes were detected by antennae on 4 shorter receiver masts. Inside, operators kept a vigil day and night. They were capable of detecting incoming aircraft up to 120 miles away. By 1940, 21 radar stations were linked to command centers buried deep underground out of reach of German bombs, where the Battle of Britain